Okay, let's take a slightly more complicated example. There is an ionic compound, and in fact I've got several bottles of it here in the chemistry lab, that has the formula AgNO3. Now the first thing you notice about this is that it is clearly not a binary compound. Why not? Well, because it contains three elements: silver, nitrogen, and oxygen. Nitrogen and oxygen are nonmetals. Silver is a metal, so you know this has to be an ionic compound. In fact, silver is a transition metal, so you don't know the charge in the cation that it forms. But you're going to figure it out based on what's present in the rest of the formula. Now, you might look at this and say, okay, NO3, nitrogen forms a 3- anion. Each of the oxygens forms a 2- anion. That's a total of 9-. Does that mean that the silver has a 9+ charge on it? Well, that should look ridiculous to you because it is ridiculous. That, in fact, is completely and utterly wrong. So I'll draw a big red line through it. And in fact, what this consists of is a polyatomic ion. In this case, silver exists as a cation with a single positive charge. The nonmetallic elements, the nitrogen and the three oxygens, do not exist as monatomic anions. They exist covalently bonded together as the polyatomic ion NO3-. Okay? So to name this compound, we'll do as we did before. We'll name the cation, silver 1. Well, what's NO3- called? Okay? Well, you're going to look that up on your nomenclature sheet, one of the yellow sheets of paper I gave you at the beginning of the unit. This is what your nomenclature sheet looks like. It's got the names and formulas of a bunch of different polyatomic anions and cations. And if we look around, we'll see, oh, there it is. NO3- is called the nitrate anion. So I'll call this silver 1 nitrate. Let's do some more examples. COClO32. Now I think that might be the first time that you've seen parentheses in a formula. Parentheses are used to surround a polyatomic ion when there is more than one ion per formula unit. So what this means is that I have one cobalt cation and two ClO3 anions. Now, I don't expect you to know the charge on the anion that has the formula ClO3, nor do I expect you to memorize the name, so we'll look on the nomenclature sheet and we see ClO3- has a single negative charge, and the name of the ion is chlorate. So to name the compound, I will name the ions. Oh, let's add in the charges. Minus, minus. Oh, okay. If there are two chlorate anions and each one has a single negative charge, that means the charge on the cobalt must be 2+. So I'll name the cation not just cobalt, but because cobalt is a transition metal, I'm going to call it cobalt 2, followed by the name of the anion chlorate. Do not call this cobalt dichlorate. We do not use prefixes like mono, di, and tri when naming ionic compounds. We save those for molecular compounds. Let's try another one. NH4,2SO4. Actually, try that one yourself. Pause the video and give it a shot. So we'll break that apart into its ions. NH4, if we look on the nomenclature sheet, we see that NH4 is a polyatomic cation that's called ammonium. So I will write out the symbol of that cation, NH4+. SO4 has a charge of 2-. And using the names from the nomenclature sheet, I'll call this ammonium sulfate. Just as we did before, we can go in the opposite direction. We can go from the name of the compound to the formula. Okay? I'll do the first one, let you try the second one. Potassium, well, I know that the potassium cation has a single positive charge based on its position in the periodic table. Dichromate. Now, I know I just said a few minutes ago that we don't use prefixes like mono, di, and tri when naming ionic compounds, but it turns out that dichromate is actually the name of a polyatomic anion. It has the formula Cr2O7 2-. So I'll write out the formula, Cr2O7 2-. Let's make sure we understand what this formula means. It means that I've got, in the polyatomic anion, I've got 2 chromium atoms, 7 oxygen atoms. The 2- charge applies to the entire ion. So using the principle of electrical neutrality, I see I'm going to have 2 potassium cations for each dichromate anion. So I'll call that K2Cr2O7. Notice I did not use parentheses around the dichromate because there's only one per formula unit. Why don't you pause the video and try the last one for yourself? Okay, manganese 3 sulfite. Manganese has the symbol Mn. The 3 in parentheses in Roman numerals tells me the cation has a 3+ charge. Sulfite, let's check our nomenclature sheet. Oh, there it is. SO3 with a 2- charge is named sulfite. So I'll write the symbol SO3 2-. If my cation has a 2+ charge, and if my cation has a 3+ charge, and my anion has a 2- charge, I need 2 manganese cations for every 3 sulfite anions. And to indicate that there are 3 sulfite anions per formula unit, I'm going to put parentheses around the SO3 and a subscript of 3 after it. Okay. Finally, let's talk about how we name binary molecular compounds. There are actually 2 systems for naming binary molecular compounds. One of them is the prefix system, which uses prefixes. The other is called the stock system, which uses what are called oxidation numbers. We're going to learn later in the year what oxidation numbers are, but we're not going to use the stock system, mainly because I don't like it. So here's how we use the prefix system. Step number 1, of the 2 elements in the binary molecular compound, name the less electronegative element first. Use a prefix to specify how many atoms there are per molecule. However, if there's only 1 atom, you do not use the prefix mono. We name the second element next with a prefix to tell how many atoms there are per molecule using the IDE ending. And if an element begins with a vowel, you can drop the O or the A at the end of the prefix just so it doesn't sound quite as clumsy. Okay? I will give you the prefixes on the nomenclature sheet, but you probably know these. 1 through 10 is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So let's do some examples. N2O. I'll name the less electronegative element first, which is nitrogen. Because there's more than 1 nitrogen atom, I will use a prefix to tell how many there are. The prefix for 2 is di. The second element is oxygen, so I will use the root of the name oxygen and add the IDE ending. And then to specify that there is 1, I will use the prefix mono. Monooxide sounds a little bit clumsy, so we normally just call this dinitrogen monoxide. NO2, on the other hand, I again start with nitrogen, but because there is only 1 nitrogen atom per molecule, by convention we don't use the prefix mono with the first element, so I just call it nitrogen. The second element is oxide, but now that there are 2 of them, I use the prefix di, so this is nitrogen dioxide. P2S5, pause the video and try that one on your own. So I'll name the first element phosphorus, and I'll give it a prefix di to indicate that there are 2 phosphorus atoms per molecule. The second element is sulfur, so I'll use the IDE ending, sulfide. Now I have 5 sulfur atoms per molecule, so I'm going to use the prefix for 5, which is penta. So the name of the molecule is diphosphorus pentasulfide. Closer together. Okay. We can go in the opposite direction as well, that is writing the formula based on the name. Carbon tetraiodide. We start with carbon, the less electronegative element. There is no prefix, so we presume that that means that there is 1. Iodide clearly is based on iodine. The prefix tetra tells us that there are 4. So I'll write the formula CI4. Phosphorus trichloride. Again, there is no prefix, so that means that there is 1 phosphorus. Chloride clearly is the element chlorine. The prefix tri tells us that there are 3 chlorine atoms per molecule. For the last one, why don't you pause the video and try this on your own? Disilicon hexafluoride, a little bit more complicated. Silicon is the first element. The prefix di tells us there are 2 per molecule. Fluoride obviously comes from fluorine. And the prefix hexa tells us that there are 6 fluorines per molecule. Si2F6 is the formula. Okay, well that basically is how you name binary ionic compounds containing polyatomic anions, and binary molecular compounds.